Hello, welcome back to Parametrics with trig identities. The next question I'm going to look at is question 8. And the good thing about question 8 is x and y are both in terms of sine, but we've got sine t and we've got sine 3t. Now normally we would see sine 2t and we would think, oh, I could use the double angle formula here, but we can't with sine 3t. So there's a little bit more work to do with this one. I will show you what to do with sine 3t up here, and we'll probably want to work on that first. So sine 3t can be rewritten, and this is quite common practice, to write as sine 2t plus t. So you'll know that from the addition formula we could rewrite this as sine 2t cos t plus cos 2t sine t, and then I can probably start rewriting this all in terms of sines in one way or another. First thing I notice is that I've got sine 2t here, which I can use the double angle formula on. It's going to be 2 sine t cos t, so that's the double angle formula bit, and then that's times another cos t. And then I can consider what to use for the cos 2t bit. Well, there are 3 different options for cos double angle formula, and I probably want the one involving sine because I feel like I want to rewrite this all in terms of sine. So that's going to be 1 minus 2 sine squared t times sine t. So it's all looking quite complicated at the moment. I'm going to try and simplify this a bit, and so we can get it all a bit nicer to bring in the x eventually. So this will be rewritten as 2 sine t cos squared t, and then this will be written as sine t, if I expand it, minus 2 sine cube t. A lot of work so far. We're nearly there though, nearly there. Finally, if I want to write this all in terms of sine, I'll need to change this cos squared, and remember I can write cos squared as 1 minus sine squared. Okay, we can breathe a little bit now because this is all in terms of sine, but I just want to finally simplify that once more, or maybe once or twice more. If I expand that, I get 2 sine t minus 2 sine cubed t plus sine t minus 2 sine cubed t, and simplifying all of that would therefore be 3 sine t minus 4 sine cubed t. Right, I'm going to put a box around that because we've done a lot of hard work and we found an expression for y. Now this is very, very useful because what I've done is I've broken away that 3t angle and I've turned it into a t angle. Very useful, because now I'm going to come over to here and just look at bringing in x, and x is equal to a third sine t. So I could rewrite that as 3x equals sine t. And notice that I can substitute that directly into this now. So all the hard work really is done in all of that work up there. And we're going to now rewrite this now so it's Cartesian. So bringing this back down to here, I've got y equals 3 sine t, and remember sine t is 3x, minus 4 sine cubed t, which is that. All I need to do now, because this is Cartesian, but it does want me to write it like this. It's looking like it's getting there, but I just need to rewrite it so it looks like that now and simplify it a bit. Okay, so I get y equals 9x minus 4, and I need to do the cube bit first. It's going to be 27x cubed. Expanding that out, I'll get 108x cubed, and it looks like I can pull out a common factor of 9 and a common factor of x, and that's going to leave me with this, and that is now in the form above, y equals ax brackets 1 minus bx squared. That's what they wanted for part A. Okay, in part B it says state the domain and range of y equals f of x in the given domain of t. Remember, the given domain of t is this, and so what I need to do is consider what happens to the x values and what happens to the y values in this given domain. So considering what happens when t takes values between 0 and pi over 2. Well, let's first consider this one. X is a third sine t. Well, even think about what happens for the graph of sine t in these values. It goes up to 1, and multiplying by a third will therefore go up to a third. So not including values 0 and pi over 2, x then becomes between 0 and a third. So that's your domain for y equals f of x. For the range, we'll need to consider y equals sine 3t. What I could do is be a little bit sneaky and say, why don't I sub in pi over 2 here? That would be sine 3 pi over 2. Well, ordinarily sine of 3 pi over 2 would be over here. I could also think, well, I could squash this by a factor 3, in which case there'd be 3 curves in the space 0 to 2 pi. What happens when I get to pi over 2? I already hit minus 1. Now, when I get as far down as that, I'm not actually going to include minus 1 because we're not including pi by 2. Likewise, I don't include 0, but I will include 1 because 1 is between the values of 0 and pi by 2. So this time I'm going to go down to minus 1 but not include it, and I'm not going to go up to 0, I'm going to go up to 1, and I am going to include it because it sits between these values of 0 and pi by 2. So there's your range. Okay, so a bit of a long question, but not too bad. This bit at the top is probably the longest part of that. Let's have a quick look at question 9 then. Question 9 looks a little bit messy because of the result they want you to get, but it's probably not too bad actually. Okay. This is kind of similar to the last question, and we're looking at relating cos and sine, and you notice here we've got not sine of t but sine of t minus pi by 6. I'm going to start with that bit first and then I'll come back over to the x's. And what we did in the last question was we used the addition formula to kind of simplify that, and we can do that again by using the rule for sine A minus B, and it would be this. Okay, so we get something like that. What I could do now is evaluate what cos pi by 6 and sine pi by 6 are to just simplify all of this. So I would get cos pi by 6 is root 3 over 2, and that's times by sine t, and sine pi over 6 is a half. So I get this, and it's still not Cartesian, it's still not in terms of x and y's, so I still need to find out an expression for sine t and cos t, and that's where I'm going to come back over to what x is. Now the first thing I could do, most obvious thing, is divide by 2, to give me cos t. Bam. Right, that can already go directly into the equation, but I need to find something for sine t now, and the way we do that is by using our favourite identity, sine squared plus cos squared is 1. So in order to do that, I'll need to square both sides, and then say that cos squared is 1 minus sine squared. And then a little bit of rearranging would give me what sine is. So sine squared is going to be 1 minus x squared over 4, and sine t then is the square root of that. Now you may be thinking, well, isn't it plus or minus? Well, it would be, generally speaking. In this case, we're looking at a domain of 0 to pi, okay? Which means that what are the possible values that x could take? Well, for cos being between 0 and pi are only positive values, and therefore x can only be positive values. Cos is going to be only positive, and sine actually in that range of values is also only positive. So between 0 and pi, sine is positive, and so we're going to take the positive root there. Okay, I can put both of those in now. I'm going to speed towards the end because there's not much more to consider. So I'm going to get root 3 over 2 times by this minus a half times by this. And all I need to do now is kind of simplify it so it looks like what they've got there. So I'm just going to quickly work through the rest of it so you can see what that looks like. Straight away I can work with the second term to just give me this. Okay, what I'm also going to do is take this root 3 inside. Because it's a root 3, I can multiply everything inside of that by 3 then, and I'll get this. And then what I could do is consider a factor of a quarter, because I need a quarter outside, which means I need to times everything by 2. And that would be something like that actually, because I could also pull out the quarter on the x over 4. Finally then, I could take a 2 squared inside. Let's see, I could call that 2 squared inside. I've done that because I've taken it inside the root, so root of 2 squared is 2. I've done that so that I can simplify what's in there. That's 4, so if I multiply that by everything I get 12 minus 3x squared minus x, and that is exactly what they wanted. Okay, finally it wants me to kind of define what the domain is, which is between minus 2 and 2. Well, if we consider then when t is between 0 and pi, what happens to x? Well, x is 2 cos t. Okay, is 2 cos t, and as we hit pi, which is here, we're going to go between 2 and minus 2. So that's going to be your domain. Okay, that's question 9. I'll do another video on some more of the harder questions in a bit.